Let us now go for another nuclear reaction called nuclear fusion. As the name itself suggests, this type of nuclear reaction involves fusion of two lighter nuclei. Two or more lighter nuclei are fused to get a heavier nucleus. Along with the release of large amount of energy. Let me give you an example. Look at it. Lighter nuclei are fused to get a heavier nucleus in which large amount of energy is released. But see, when these lighter nuclei are brought together for fusion, they repel each other. So to overcome this repulsion, they have to be preheated to millions of degrees temperature. So these reactions are also known as thermonuclear reaction. Thermonuclear. That is the reason why they say if an atom bomb is to be exploded, if a hydrogen bomb is to be exploded where the principle involved is nuclear fusion, then atom bomb needs to be exploded because getting millions of degrees temperature is not that easy. So by exploding atom bomb, they get millions of degrees temperature, using which a hydrogen bomb can be exploded. Okay. So hydrogen bomb is more powerful when compared to atom bomb. Principle involved in hydrogen bomb is nuclear fusion. You know, the efficiency of fusion, energy released per gram, is greater than that of fission. If we look at the percentages, in fusion, 0.7% of the total mass is converted into energy. I mean, the mass defect is 0.7%, whereas in fission it is just 0.1%. This also says why a hydrogen bomb is more powerful than the atom bomb. Okay. You know, the continuous shining of sun and stars is due to nuclear fusion reaction that take place in them. We know that helium was discovered in sun's chromosphere. On a complete solar eclipse day. This helium, whatever was found in sun, was actually found to be formed by the nuclear fusion reaction that occurs in sun. Of course, in stars. Okay. Now let us go for two very important things. One is uranium dating and the other one is carbon dating. First of all, uranium dating. You know, uranium dating is used to know the age of rocks. See, in this, generally, the rocks contain uranium 92 to 38, which goes on disintegrating to form lead 82,206. Based on the amounts of lead formed, nothing but uranium disintegrated. Isn't it? And uranium left, age of rock can be determined. See, it can be given as lambda is equal to 2.303 by T into log. See, if you want, in general, this has to be N naught and this has to be N, right? N naught, I mean the initial number of atoms can be given as it is in fact the sum of uranium disintegrated plus uranium left. Uranium disintegrated is nothing but lead formed. Okay. By this N is nothing but the number of atoms of uranium left. Isn't it? So that is how the same can be modified as lambda is equal to 2.303 by T log N naught can be given as uranium 238 left plus lead 206 formed by uranium 238 left. Isn't it? That is how we can find the age of rock, that is T. Okay. Now let us go for carbon dating. See, carbon dating is used to know the age of fossils. Fossils are those which are dead long back, right? See, in this, just like in uranium dating, where uranium decays, here carbon 614 decays and finally forms a stable nitrogen 714. Same. Based on the amounts of nitrogen formed and what is nitrogen formed? Nothing but carbon 14 disintegrated. And of course, carbon 14 left. Age of fossil can be determined. Okay. Now, the same can be given as lambda is equal to 2.303 by T into log N naught by L. N naught, nothing but initial. This can be given as, what we have started with can be given as the sum of nitrogen formed or say carbon disintegrated and carbon 14 left out. The same as the previous one. And this, of course, is left at that time. This can simply be given as the number of atoms of carbon 14 left. Okay. So let us modify this, giving lambda is equal to 2.303 by T into log T14 left plus N14 formed by again C14 left. Okay. This is how the age of fossils is determined. Next, it is nuclear spalation. Interesting. It is a type of NTR, nuclear transmutation reaction, wherein we get large number of nucleons along with the product. See, this is a transmutation reaction in which large number of nucleons are formed along with the product nucleus. Okay. Let me give you an example. Even copper 2963 is bombarded with a particle. We get chlorine 1737. Along with this, of course, 14 protons and 16 neutrons. 17 plus 14, 31. 29 plus 2, 31, balanced. 63 plus 4, 67. Here it is 37 plus 14, 51 plus 16. Yes, 67, balanced with respect to atomic number as well as mass number. And look at this, you got too many nuclei. 14 protons and 16 neutrons. A large number. Of nucleons are formed in. Okay. This is nuclear spallation reaction, which of course was proposed by Seaborg. Okay.